So basically, whenever we have a completed square, whether it's a plus b or a minus b, whatever a is and b is, we can take that completed square and create a perfect square trinomial. Okay? Any questions about how I got to my resulting equation, this one right here? About what I'm doing here, how I got here. Any questions? Okay. And then say I have a minus, so say I have x minus 3. Well, this would apply to this one right here. And basically, you're just allowed to do the same thing, but you're more than likely going to get an equation that follows this form. So again, that basically says that I can take that factor and multiply by itself. Then I want to do first inner or first outer, inner last. And that gives me x2 minus 6x plus 9. Okay, so again, you're just doing the same thing, but you're given that this is a plus sign, you'll end up where these are plus signs, and given this is a minus sign, you'll likely end up where that's a minus and that's a plus sign, like you do here. So that's basically what it's saying. But we know how to go about expanding that completed square and creating an equation. What we could also do, given this information, is we could work backwards to find values. So say I want to work backwards to find what k is. So that I know that I have x squared minus x, or k times x plus 169. Well, can I work backwards to find k? Well, yes, I can, in fact, work backwards to find k. And what I would do is I would use the value that I'm given here, 169. And what this is basically telling me is that whatever value I get here for 169, well, it follows this form right here, first of all. Because you have a minus and you have a plus sign. There you have a minus and you have a plus sign. And so what this is telling me is that whatever value I get for there, it is squared by something. So it's telling me it is basically what b is squared. And so because of that, I can do 169 squared to find out what my original b was. So I'm able to work backwards. And so this gives the square root of 169 is 13. And so because of that, now I know that my b is 13. My a is always x. My b is 13, and then I do square. So I'm able to work backwards. So let me just go over that one more time. Because my resulting equation is in the form x squared minus kx plus 169, that should recall me to this right here, where I have a squared to a plus b plus b squared. So basically what this is telling me right here is the relationship that I'm going to arrive at whenever it comes to my original completed square. So it's going to tell me, well, whatever a was, it's going to result in where a is squared. Whatever a and b was, this will result in whatever 2 times a times b is. And whatever b is, my end result, my c, will end up to be whatever b squared is. And so because of that, because I know my c ends up to whatever b squared is, what I can go ahead and do is solve for b by taking the square root of 169, and that is 13. So basically, I'm taking, if b squared is equal to, I got 169, how can I solve for what b originally was? So that's you taking the square root, and then you're able to take the square root. And then because here it originally was in the form x minus b, I know to use a minus sign there, or a minus b, I'm able to use a minus sign there. And so I worked backwards and found my original completed square. And so now I am able to expand this if I want to solve for k. And so again, first, outer, inner, last. X2, 26f. And so where is my k? My k is located right here. And so therefore my k is 26. Okay. So basically what we're doing is given these square root relationships, I'm able to work backwards to find a specific value. In this case, I'm able to find k, given the relationship that it tells me happens between my completed square and when it creates a perfect square trinomial. Okay. Any questions here? How I got k is equal to 26, maybe? Any questions? Okay. All right. So now we're going to look at the square root property of equality. The square root property of equality basically tells me if I am given a value of something squared, x squared, my k, whatever my k is, in order to solve what x is, I'm going to get a k that is both the positive square root of k and the negative square root of k. So more explained, let's say I'm looking for x squared equals 25. Okay, so I'm given x squared equals 25. What I notice here is that 25 is my k because my original tells me that I have x squared equals k. So k is the 25. 25 is greater than 0, which this is telling me here. K is greater than 0. And basically what it's telling me, if k is greater than 0, and if x squared is equal to k, well then whenever I'm looking to find my x, what I want to do is take the positive and the negative square root. So what does that look like? Well, say I'm trying to solve for x. I have x squared equals 25. Well, whenever I take the square root of both sides to negate my square root and solve for x, what I'm going to do is take the positive and the negative square root of 25. Why is that? Well, because if you think about it, the positive square root of 25 is 5, and the negative square root of 25 is negative 5. And if you really think about it, if I take positive 5 squared, I get 25. But if I also take negative 5 times negative 5, that also gives me a positive 25. And so that means that both 5 and negative 5 are possible solutions of my equation x squared equals 25. So whenever k is greater than 0, what I want to keep in mind is that I need to find both the positive and the negative solution of my perfect square, because both of those would in fact give me the value that I'm looking for, in this case, 25. Okay, but we'll look at another example right now. So say I'm not just given exactly x squared, but in this case, I'm given an equation. X plus 3 squared equals 25. Well, this is basically giving me the same thing. It's still telling me x squared is equal to something that is k. And k is still greater than 0, right? 25 is greater than 0. And so because of that, what I know is that whenever I solve, I want to get both the positive square root and the negative square root. So in order to solve this, I need to take the square root of both sides, which gives me x plus 3 equals the positive and negative square root of 25. And so now I go ahead and solve. X plus 3, what is the positive square root of 25? 5. X plus 3, what is the negative square root of 25? Negative 5. And now what you'll realize is I'm going to get two different x's, but both of those x's will be a solution to my problem. So now I'm going to solve for x because I need x. So minus 3, minus 3. 5 minus 3, x is equal to 2. X plus 3, so x minus 3 minus 3, x equals to negative 8. So what I end up here is with 2 solutions to x. And so the reason I apply the square root property of equality is because without taking both the positive and the negative of my perfect square, I wouldn't get both of these solutions. And what this is telling me is I have, in fact, 2 solutions for this equation. X plus 3 squared equals 25. Okay. And if I wanted to check those, I could. Plus 3 squared equals to the square root of 25. So I could say, I'll plug in my 2. That gives me 5 squared is equal to the square root of 25. Which is a true statement. Square root of 25. Okay, which is also 5 squared, or negative 5 squared. Is equal to 25, sorry, not the square root. So we started with 25. And it is true that 5 squared is equal to 25, and it is true that negative 5 squared is equal to 25. So both of those x's would allow me to solve that problem. Okay, any questions here? So whenever you have something in the form x squared is equal to a whole value k, and if k is greater than 0, then what you need to know and remember is that you need to find the positive square root and the negative square root of k, because both of those solutions will solve your problem. Okay. So now we're going to look at factoring a perfect square trinomial and applying the square root property. So basically, what I'm going to be able to do is solve this equation by both factoring it out and by also using or applying the square root property. So I'll be able to find the solutions for my x. Okay? So the first thing I want to do is find a perfect square. There is a way that we can find the perfect square, and we'll see this in our next example. But the way you find this perfect square is you basically take b squared, b minus 2 squared. So you have 12 Actually, no, we're not going to apply this in this case. We'll see it being applied in the next case. I don't want to jump ahead. So basically, if I wanted to find the perfect square here, what I need to find is something, a factor that can be multiplied by itself to get this equation. And that is x plus 6 squared. So x plus 6 squared equals 25. The reason I know that x plus 6 squared is my perfect square is because this value needs to be multiplied together to give you your c and added together to give you your b. So 6 times 6 gives me my c, and 6 plus 6 gives me my b. And so I know that that's the perfect square I can use. So it needs to be multiplied together to give my c and added together to give my b. And what I mean by this is this equation is in this form. So multiplied together to give me my c and added together to give me my b. Okay? So now I have my perfect square. So now that I'm able to factor and find my perfect square, now what I want to do is apply the square root property to solve for x. I'm going to apply the square root property. Which we saw is basically take x squared, x is that whole equation, equals to 25. The square root property tells me if my k, this would be my k, is greater than 0, which it is here, then I need to take both the positive square root of that and the negative square root of that. So square, s plus 6 positive square root of 25, which is 5, and the negative square root of 25, which is negative 5. So I'm taking both the positive square root and the negative square root, which we solved in the other problem, right? And so now I'm going to solve for x. Minus 6, x is equal to negative 1, minus 6, x is equal to negative 11. And so therefore, I solved for both of my solutions for which x could be. Okay, so the first thing I want to do is factor the perfect square, because once you factor the perfect square, you get your equation in the form x squared is equal to k. Now that you have something x squared is equal to k, now I know that I can apply the perfect square root property, which is basically x is going to be equal to the square root of k and the square root of negative k. Lastly, what I'm doing is I'm simplifying each side. And then I can solve for x. Okay. Any questions about what I did here to solve for x? So first factor, then apply the square root property. Applying the square root property will help us solve for x, which we're looking for. And once we solve, we see that x can either be negative 1 or negative 11. Okay. We're going to look at one more property, and that is solving a quadratic equation by completing the square. Okay, so we're going to solve a quadratic equation by completing the square. Whenever we are asked to solve a quadratic equation by completing the square, what we're going to do is we're going to add whatever b divided by 2 squared is to both sides of the equation and factor to the left side of the remaining equation. So we'll see what this looks like. So say we're trying to solve the quadratic equation x2 equal to 18. So I'm trying to factor this and I'm trying to solve for it. So I'm trying to solve for what x is. Okay. Well, the first thing I'm going to do is I'm going to try to complete my square. I'm trying to get a completed square so that I can apply the square root property and solve. Okay. The way that we complete the square is we want to get our equation into the form x squared plus bx equals 2c. And because of that, I want to subtract my 7 and move it to this side because I want all my c's to be on this side, and I want x squared plus bx on this side. Okay, so I'm going to move my 7, x squared minus 10x equals 11. Now what I want to do is actually complete the square. The way that I complete the square is I use the equation b over 2 squared. That will give me a value that allows me to create a perfect square or a completed square. So b, this is my b, 10 is my b, and so that's what I'm plugging into here. Or I'll do it over here so I don't get confused. So I'm doing 10 divided by 2 squared. 10 divided by 2 is 5. Squared is 25. Okay? So now that I know that 25 would help me complete my square, what I'm going to do is take that 25 and I'm going to add it to this equation. And I'm going to add it to the tail end because I can't just come in and add a variable and can't add it to the other side. I have to add it to both sides. So I'm adding my completed square to both sides. Then I'll just simplify. So x squared minus 10x plus 25 equals 36. So this is where I'm at. Okay? Now what I have is an equation that gives me a completed square or a perfect square. And in this instance, it is x minus 5 squared equals 36. How do I know it's x minus 5? Well, here I have a minus sign. Here I have a plus sign. Let's go back. If I have a minus and a plus sign, I know that I'm going to have a completed square which has a minus sign in the center. So that's why I have that minus sign. And if I were to factor that out, I would get this equation here. So I can also test it by actually doing the factoring out and see if I end up with my original equation. So now I'm here, x minus 5 squared equals 36. Well, what does this look like? Well, this should help recall the x squared equals k, the square root property, right? That's what it looks like. And so because of that, I know that because my k is greater than 0, I know that I need to take the positive square root of k and the negative square root of k. So let me move it over here. So I need both the positive square root of k and the negative square root of k. So to the square root, and then I get x minus 5 squared, or x minus 5 needs to be equal to the positive and the negative square root of k. The positive square root of 36 is 6, and the negative square root of 36 is negative 6. And so now I can solve for my x's. Plus 5, plus 5, plus 5, plus 5. This x is equal to 11, and this x is equal to negative 1. So that's how you solve. So basically, we're putting everything together here. The first thing we're doing is we're going to complete the square. We're trying to create an equation that allows us to create a completed square. So complete the square. After we complete the square, we're here. We want to factor to a perfect square trinomial. Or you want to factor that perfect square. Okay? And then after we do that, we apply the square root property. And then lastly, we solve. Oh. So basically, we're putting everything we learned today together to solve for our values of x. Okay? So here's the part where we are completing that square. Here is the part where we are applying that square property. Actually, more like all the way to here. And then lastly, here's the part where we're actually doing that solving. We're finding our solutions for x. So we're applying everything that we looked at today. Okay? Any questions?
Yes, miss. Where do you get the answer in the negative 5? Like, I know you get the negative x plus 25.
So how do I get right here?
Yes.
Okay. So the way that I do it is, let me rewrite it and I can help you solve for that. Just because that's the only thing you need. Okay. So we are at x2 minus 10x plus 25 equals 36. Whenever you're trying to factor your perfect square, what you want your equation to be is you want it to be something that is multiplied together to give you your C, this is your C, and added together to give you your B. So a value that is multiplied together to give you your C and added together to give you your B. The way that you can technically do that is you can find all the different factors of 25. So 1 and 25, there's a lot. Hold on. Second. I just want to make sure I'm not missing any. Then you get 3 and 5. I think that's the only factors of 25. Basically, you can list out all your factors of 25. So factors are basically two whole numbers that when added, multiplied together, give you 25. And 5 and 5, sorry. Oh, not even 3 and 5, 5 and 5. So these are the only factors of 25. 1 and 25 multiplied together give you 25. 5 times 5 gives you 25. Now that you have your factors, you want to look at these factors and see, okay, now that I have all my factors listed out, which of those factors can I now add together to give me my B? Which of those factors, when added together, will give me 10? This one will give me 26. This one will give me 10. And so because your 5s will give you 10, you know to substitute in a 5. Now, whether that's going to be a positive or a negative 5, you're going to look back to here, the square root of the binomial. And what you notice is that your equation that you're working with has a positive, negative, and a positive, or a minus and a plus sign. Here, let me write this so I can bring it over. Just so it's easier to see. Done. Oh no. Sorry guys, I'm all over the place today. Okay. Let me put that down here so we can see it. Okay. So basically, because this equation has a minus and a plus sign, this one has a minus and a plus sign. It results in a minus and a plus sign. Because of that, you know that I'm going to have a minus sign inside of my factors. So I would put the minus sign there. And because I have two 5s, I could just do squared. Because that's basically just telling me that I'm taking this factor, x minus 5 and x minus 5, and I'm squaring them to get my equation. And if I wanted to go ahead and just make sure that that's the factor that I need, I could just do my FOIL, and what I'll get is x squared minus 5x minus 5x plus 25. That gives me x squared minus 10x plus 25. So the reason I know it is 5 is basically because the factor of 5 itself, when multiplied together, gives me my 25, and when added together, gives me my 10. So that's how I know that I'm going to use 5. Instead of 1 and 25, I'm going to use the 5. Does that make sense, kind of?
Yes.
Yeah? Okay. And so that's how, once I know that I have x minus 5 squared, well, then I can just write the equation like that and then solve from there. Find my x like that. Okay? All right. So let's just try this once again, but say now that I have an equation that looks like this. Basically, we're going to apply the same steps, but just a little bit different. So in this equation, what I notice is that my a is greater than 1. So it actually has a variable there, where in my other a, I just had x squared. Now I have 3x squared. And so because my a is greater than 1, and what I mean by my a is greater than 1, the standard form of a quadratic equation is a x squared plus bx plus c. So this a would be my 3. And because 3 is greater than 1, the first step that I need to do in order to solve this is I need to get rid of that a because I can't use the different strategies that we just had if I have a greater than 1. And so the way I'm going to get rid of my a, or my 3 in this case, is I'm going to divide by 3 all the way across. That's going to allow me to get rid of my a. When I divide, that gives me x squared. 30 minus 3 is 10. 87 minus 3 is 24, or 29. And 0 minus 3 is just 0. So that allows me to get rid of my a. Now that I got rid of my a, now I have a is 1. It has an imaginary 1 there. And so because of that, I can now solve the way that we just solved previously. Give me 1 second. Yes. Okay, sorry. So basically, I don't want an equation where a is greater than 1. Because if I have an equation a is greater than 1, it's a lot harder for me to solve for x. But when I have an equation that where a is 1, or a has nothing, a is nothing's in front of the x squared, now I'm able to apply what we just learned to solve this. So here I have x squared, a is 1, or if you want to think about it, it's nothing there. So now that it's like this, I can go ahead and solve the way that we just did previously. What I want to do is get my equation in the form x squared plus bx equals c. How do I do that? Well, I need to move my c to the other side, so minus 29. Minus 29 both sides. That gives me x squared. Bx is equal to c, which in this case is negative 29. Once I have my equation in the form x squared plus bx equals c, now what I want to do is I want to complete the square. How do I complete the square? Well, I use that equation, b divided by 2 squared. My b here is 10, so I'm plugging that in. 10 minus 2. Or here I have a negative 10, same thing. Negative 5 squared, 25. So in order to complete the square, I have to add 25, but I have to do it to both sides. Don't forget to do it to both sides. So in order to complete the square, I have to add that to both sides. X squared. And our color coordinate, so it's easier for us to see. Okay, so add 25 to both sides. This will allow me to get a completed square that I can then factor out. So equals, that's negative 4. Okay, so now I have an equation. I'll write the equation here. X squared minus 10x plus 25 equals negative 4. Now I have an equation that is a perfect square trinomial. And so because of that, I can factor that perfect square. So factor. So I'm going to factor it out. Basically, a perfect square trinomial, it gives me a factor which can be squared together to give me that equation. That means it's a perfect square trinomial. So here I have a minus and a plus. Because I have a minus and a plus, I know I'm going to have an equation where it's x minus something squared, which will give me that equation. I want that something to, when multiplied together, give me 25. And when added together to give me 10, that's 5. So x minus 5 equals negative 4. Now that I have this is in the form x squared equals k. Okay. In this sense, k is actually not greater than 0. And so because of that, I'm not taking the plus and the minus of the square root of k. I'm just solving for x because there's only one solution to x because x is not greater than 0. X is -4, so that's not greater than 0. So basically, now I'm just going to go ahead and solve regularly how I would. I'm not going to take the square root of I'm not taking the positive and the negative square root of -4. So now I just solve. So x minus 5 is equal to -4. I'm not doing positive and -4. I'm just solving the regular way because my k is not greater than 0. So I'm not going to apply, in this case, the square root property. So how do I solve for this? Well, you can't solve for negative numbers, but what you can do is you can make this 4 times -1. Right? Because 4 times -1 is still -4. So I can put 4 times -1 inside that square root and it would be the same thing. And I can solve now for the square root of +4. The square root of +4 is 2. And then there's still no solution for the square root of -1. Or is there? Well, what we learned was that the square root of -1, I gotta hurry because I don't want it to die. The square root of -1 is I, my imaginary number. So basically, now I have x minus 5 equals 2i, right? The square root of -1 is I. We learned that on Wednesday. So I'm just plugging in I for that square root of -1 because I don't have a solution, but I can put an imaginary number there. Now I just solve plus 5 plus 5. X is equal to 2i plus 5. So that's how I would solve this. Give me 1 second. I don't want this to die. Okay. So basically, once again, we're putting together all of the different things we looked at today. We're even putting together something that we looked at on Wednesday. However, in this one, what we want to do is we want to make sure that A is not something greater than 1, because if A is something greater than 1, then we can't use these different ideas or these different properties to solve for x. So the first thing you want to do is get it in the form. I'll do this. You want to get it to the form. Oh, here. I'll write this here. What we did here. Okay, first thing you want to do is get it in the form where you have A is 1. So that's why we divided by 3. Next thing you want to do is get it in this form, x squared plus bx equals c, in order to complete the square. Once we have it in that form, we can complete the square by doing b divided by 2 squared. You want to take whatever b divided by 2 squared is and add it to both sides. Now what you have is an equation, which is a perfect square trinomial, which means what I can do is I can factor it to create an equation that follows x squared equals k. Now I want to solve for k. In this instance, because k is not greater than 0, I don't need to take the positive and the negative value of the square root of k. I just need to take whatever it is, whatever the square root is. There's no positive or negative square root of that. And so basically, I just go ahead and solve. I can't solve anything for -4, but I can make it 4 plus -1. The square root of a whole number 4 is 2. I can't take any square root of -1, so I'll just keep it there. But yes, I can. I can use the imaginary number is equal to the square root of -1, so I can substitute that with the imaginary number I. Then I'm just solving for x, which is 2i plus 5. Okay. Questions, concerns here? And like always, I'll go ahead and list out these different steps for you so you can use them on your own when you're practicing. But I know there's a lot of steps, so I'll number the steps for you just so you can see it a little clearer. Okay? So basically, that's the gist of today. Today, we looked at the square root property. We looked at the square root of binomial. And we looked at how to complete the square. And basically by doing all those things, what I'm able to do is I'm able to solve a quadratic equation. So solve for the x of a quadratic equation. Okay, questions, concerns? And like always, we'll go over some practice problems so you can see it being used. Okay. What time is it? Okay. Just a heads up. Am I doing it right? Okay, just a heads up that I know on Wednesday we went over something that was pretty lengthy. So I did go ahead and post just a condensed version of what we did. So basically what I did here was I listed those steps for you. So we solved those problems, but it was kind of difficult to actually see, okay, step 1, step 2, step 3, step 4, what do I do? And so those are here listed out for you. So whenever you're adding complex numbers, you do those steps. Whenever you're subtracting complex numbers, you're just completing those steps, et cetera, et cetera. And so basically I'm going to create a form like this for you regarding what we went over today. But if you want to look at this, kind of just a shortened version of what we looked at on Wednesday, that's here for you too. Okay, one more thing. I'm going to go ahead and already upload everything that is due next week after today's class. So if you want to access any of this stuff from Monday to Friday, actually, no, I won't because I still need people to do the check-ins. Disregard what I just said. I'll keep it here and I'll just do it on Sunday. Okay, any questions?
No, ma'am.
No? Okay, so I will post a shortened version of everything we went over today, all the steps, so you're not too confused. But we will go over practice problems soon. So if there's no other questions, have a great weekend. And I will see you guys Monday. Bye, guys.
Bye, miss.
Bye.